Wonderful. Well, thank you for the introduction and thank you for having me. It's wonderful to be joining from across the water, as you mentioned. I'm typically in New York, but in Maine at the moment. So for those of you who don't know me, I'm Elizabeth Nichols. I'm a former project manager with 3XN Architects based out of Copenhagen. I was working out of their New York office. And today I wanted to talk, well, this evening for your time zone, I wanted to talk to you about T3 Bayside, which is a project that 3XN has been involved in since 2018. It's now under construction. And this project was, for me, my first foray into mass timber and the mass timber world. And in addition to that, for a lot of the team that I worked with, including some of the members of 3XN, as well as a lot of the engineers who worked on the project and the landscape architects, even a lot of the local architects that we worked with, it was also their first mass timber project. So I wanted to talk about this project in that context or framework of, what it's like to work on one of these projects for the first time, and what are some of the challenges that came up during the process. We all were really learning at the same time. So the project is, so I'll talk about it in that sense and basically walk through the different phases of the design project, of the design process, and talk about some of the challenges during each phase that we encountered. So the project is developed by Hines, who's a global developer, and this is one of their T3, what they call T3 projects, which stands for Timber, Transit, and Technology. And, as much as I think us architects like to, we maybe have some struggles with developers or even general contractors, I think it's really wonderful that this developer is getting so involved in mass timber. I think particularly in North America, it's important to have these large developers also get into the movement. And so this is, as I mentioned, their third T3 project. They have previously completed T3 Minneapolis in Minnesota, which was a very successful project that they completed a few years ago. You can't tell from this exterior image, but it's also a tall mass timber project. And while we started this project, they were working on developing T3 Atlanta. This is an image of that project. So the client had some experience in mass timber building, specifically of office buildings. But like I said, a lot of people on the team did not. The project is located in downtown Toronto. So this is, you can see the city in the background, and it's on this new revitalized development on the waterfront called Bayside. And I think it's a good example of using mass timber in a former industrial area. I think it's a good and appropriate place to do that, where you have large swaths of land where you can build large projects, but you also want to perhaps evoke and reference what was once there, which was formerly industrial buildings, since mass timber has a long history, in a sense, of being used for industrial buildings. Just now we're using it in a different way with a different kind of technology. And the completion date is estimated to be towards the end of 2022 or early 2023. Right now, we're still in the ground. There is a basement on this project, a concrete parking basement. And so they're at that phase, but they're getting close to starting to erect the timber itself. And here's just another image of where that site is, that entire Bayside area that's, as I mentioned, being revitalized. And the project is one of a pair. So there's two buildings that are being developed, and two office buildings. And surrounding these office buildings are a series of residential and mixed use projects, also all large scale projects. Two of them on the right side here are projects that 3XN is also developing and are also under construction, but they're residential projects. So these are the two office projects in the area. And it's worth noting that these are speculative office projects, which means that we do not yet know who the tenants will be. The client thought that there may be the possibility that one tenant would buy both of these buildings, lease both of these buildings to create a kind of community space, or that these buildings could house many, many tenants. So given that we didn't know who the tenants were going to be on day one, and certainly in 10 years or in 20 or 50 years, one of our main design goals was how to design flexibility into the project. And as I'll talk about later, mass timber works very, very well for that. It's something that 3XN thinks about a lot in their projects, is designing in flexibility, understanding that, particularly looking back now in the COVID-19 pandemic, office space can, definitely is going to transform in the future, and we don't yet know what the needs and requirements of our future tenants may be. So it makes sense to design for flexibility now. And in respect to that, we wanted to utilize a lot of work that GXN, which is 3XN's sister research company, has done in the space of designing for disassembly, which basically means if we think about our building as a series of components, how can we design them so that in the future, we're not only designing them to, of course, be constructed, but we're also designing them to be deconstructed or perhaps reconstructed in a different way. And how can we design for that now in the most efficient way? And again, mass timber works very well with that idea. So we wanted to make sure that we are finding ways for the tenants themselves to be involved in potential future flexibility of the spaces. Then another main design goal of the project was, how do we think about these buildings as being centerpieces for the community and the neighborhood? Since these are the two creative office spaces in the neighborhood, how can we create a place where these residents would have a space to go to get some coffee, or perhaps to have even a larger community event held in those spaces? This is really the gateway to the community. So we didn't want this to just be an office island in the neighborhood, but we wanted it to be something that would welcoming and bringing in the community. And so sort of that idea of wanting to enhance the community and also wanting this building or series of buildings to be flexible is what led to this idea of this what we call the steps, which are a series of interconnected spaces that move up and step around the building. And that starts at the lobbies, which are at the corner, and then becomes a series of community spaces. So there's a space on level 2 and a space on level 3 that are all interconnected. And these are public spaces, so they're intended to bring the community or passersby or visitors into the building, up and into the building, and activate this plaza that serves as a central gateway to the neighborhood. And then they also, in an ideal world, and especially if one tenant were to take over the entire building, connect up through these other steps that wrap around the building. And that's where we decided to focus our energy in terms of using mass timber as a means to create flexible spaces for tenants in the future. So all of the spaces that are called out on the facade and that wrap around the facade, these are the places where tenants could transform a single height space into a double height space. In theory, you could do that anywhere in the building, but what we did is we built in using, thinking about mass timber, we built in ways to do that so that it would be easier for tenants to actually transform their space from a single to a double height space. Or say if one tenant were to occupy 4 floors, then they may do that in 3 different areas to interconnect those 4 floors. And I'll talk about that in more detail. And here you can see the same principle of these double height spaces that wrap up and around the building, or these flexible spaces. So I'll talk about concept phase and what was our big challenge here. And it really was looking at, well, does mass timber make sense in this particular project? There are some times where it's probably just not going to make sense, and it actually makes sense to use concrete or steel, and it's something that you do need to evaluate first. We definitely wanted to use timber on this project. The client wanted to because of their past experience with timber, but we did need to make sure that it made sense and would be feasible for the client. So we looked at what would it mean if we built this structure in timber, and what would it mean if we built it in concrete. And there's a few different considerations. First of all, structure. What we found generally was that on the left-hand side is the basic floor plate that we'll look at a few different times. The typical floor plate is, what if we did this floor plate with concrete beams and, columns, and versus with timber on the right-hand side. And you can see a big difference is that we can span a lot more in concrete. Now, we could achieve the same spans with mass timber, but it would mean that it would no longer be cost effective to do so. And you would have much deeper slabs than would be desirable to do that. So that was one consideration is, okay, we probably will get a much smaller structural bay size with timber, but given some other benefits, maybe that's okay and going to be acceptable to tenants. And we, of course, considered aesthetics, and we all felt like clearly timber is, beautiful material. The client already had experience with tenants who were interested in wanting to have this timber aesthetic, this industrial vibe for creative office tenants. So we definitely felt like that was going to be a positive, and that we would want to expose the timber as much as possible and celebrate it. And then in terms of cost, and probably some other lectures have talked about this, but I don't have the specific numbers on this, but the timber did come in as slightly more expensive, but given that we would save costs in terms of the time that it would take to construct the project, that outweighed the additional cost of the material itself. So because the timber can basically go up like an erector set and you don't have to wait for your concrete structure to cure, and because so much of the timber elements are all prefabricated off-site, that meant that the client was going to save a lot of time on site to actually construct the building, which means they're saving money. The sooner they can get their tenants in, the better for them. So that one was a bit of a wash in terms of the comparison. And then of course we talked about, and what was important to both us and the client were the environmental benefits of using mass timber, which I'm sure you've also heard a lot about by this point, but the fact that this building is going to store so much carbon. And I think also one way to think about it, and that we were talking about it now, again, kind of looking back on the pandemic, which at the time when we started this project, it was prior to that, was that it's also creating a healthier environment for the occupants inside. So I think it's, you can think about it as it's healthier for the environment outside, and it's healthier for the environment of the occupants inside. So that's another benefit. And once we decided to, grade this, we felt like this was an appropriate project for using mass timber, then we wanted to make sure that we were exposing it as much as possible. And the main way I think that we achieve that is by using a curtain wall facade system, which I'll also talk about a bit later. But that meant that we could expose from the exterior the timber as much as possible, which we thought would be, just create a good environment for passersby, but also kind of function as a way of educating the public about mass timber construction techniques. So that really became our third design pillar, if you will, along with creating flexibility and enhancing the community. The third pillar was really, okay, then let's celebrate and expose the mass timber as much as possible. So during the schematic design phase, our big challenge here was, how do we maximize the size of the building given the fire code regulations or the building code regulations? And what's interesting is that the building code at the time of working on this project was a bit behind in terms of what we knew is safe and achievable for mass timber. So we knew that we could, and there were already projects that had been built around the world that were taller than what the building code that we were working with allowed for, which was a mass timber building of only about 6 stories of height. But given some of the examples of projects already built around the world and the new international building code that was going to be put out in 2021 this year, we were able to work with the city to achieve a higher mass timber building height than what was prescribed in the building code. So this project is 10 floors of timber and 9 floors of timber and 1 floor of concrete at the base. And there was a few other things we had to do in order to achieve this, such as we increased the number of sprinklers. I think that this is a pretty common way to achieve a taller mass timber building, where you can make sure that you have 2 completely separate sprinkler systems, so you have 1 full backup system, which isn't typically required in building with concrete or steel. So the building height is it's 42 meters, and again that was a bit of a back and forth the way we came to that conclusion between looking at the zoning code and the fire code, and then what we knew was actually achievable with mass timber. And we worked with our structural engineers, fantastic, who had actually worked on the prior to T3 projects. And again, as I said, the ground floor though is all concrete, and that allowed us to have an overall taller building height than we would have otherwise. The floor to floor height is 4 meters, so it's quite large, especially given that the total slab thickness of each floor is only about 300 millimeters. So you get a really high clear span in each floor, which is also something that the client was, really wanted to push for their tenants. So here you can see that the concrete on the first floor, then there's a bit of a hybrid situation happening where this is the double height lobby at the corner where it meets the second floor. And then you can see the next double height space and the third floor one. These are the community spaces. We also even had the penthouse in timber. This is all mechanical space. And we looked at it being in steel or concrete, but it made sense to also have the penthouse be in timber because that also meant one less trade on site. So it's another thing to think about when you're thinking through the logistics of the construction with mass timber is who are the other trades, the other people who are laborers who are going to have to be on site. And in this case, it made sense to just stick with the people who would be constructing the timber to just keep on moving up the building and doing the penthouse rather than having to bring in a whole different trade of steel workers to then do the penthouse part. So in addition to the regulations from the code perspective on building height and number of stories, there's also, you also have to consider how much of the timber can be exposed, which is a percentage that the code prescribes. And in our case, we were fortunate where we were basically able to expose all of the timber with the exception of 2 areas within the core. So this area here, which is mechanical, and then on the right side, this area as well, which is also mechanical room and the fire escape stairs, those 2 areas had to be encapsulated or enclosed with fireproofing material like gypsum or drywall. But otherwise, these glulam columns, the glulam beams, and the slab itself were able to be completely exposed without any additional fireproofing. And actually, I'll mention with the, as we were sort of looking at the overall structure, the overall massing of the building, of course, we're also looking at what the exact structural bay needs to be. And we found that a 6 meter by 7.5 meter bay was about right in terms of, it's still a comfortable bay size for office tenants. So it's large enough, but it's not too large where you are having to utilize non-standard timber building sizes. So your glulam columns and beams, there are some standard sizes for those, and then there are special sizes that can be made. And we wanted to make sure that that the spans weren't so great that we were going to have to order special sizes of glulam columns and beams. And then the same goes for the slab, the DLT or NLT or CLT slab. We looked at all of those. The greater the spans, of course, the deeper the slab. And there's a balance of what's a comfortable span size with what's a comfortable slab depth size in terms of cost and in terms of the clear height that slab depth gives you. So what worked well here is that with the 6 by 7.5 meter or so structural bay, that meant that we could run what you see in yellow are the overhead beams, and that meant that we could run our beams only in the north-south direction. This is the north-south direction on the page. And we would not have to have beams running in the other direction, which helped with our systems that I'll show you later on, with the exception of all these perimeter beams, which run west-east. As I mentioned, we looked at a few different slab options, and we were for a while going with NLT because that choice was actually because the client had found that tenants really liked the look of NLT, which is nail laminated timber, which means you see the thin gap between each piece of wood, whereas in CLT or cross-laminated timber, which you can see on the right-hand side, it has a slightly different aesthetic because it's all glued and you don't see those gaps. So we were specifying NLT, and then as we got closer to construction, when we priced it out, for whatever reason at the time, CLT came in as slightly cheaper. So then we converted to CLT slabs, which we still think are beautiful. So I think either way, it works well in the project. And so our total slab is a 7-ply CLT that's exposed from below with a layer of acoustic mat and then a layer of concrete topping on top of that. And that concrete topping is not primarily for structural reasons or even fireproofing reasons. It's really for acoustic reasons. And if you think about dropping a heavy object on the floor or moving furniture around, it's for kind of preventing that type of noise from passing through to the floor below. The other big consideration during the schematic design phase in terms of structure was, what do we provide for lateral bracing? So because mass timber which is a fantastic quality in terms of transporting the material, because it's lighter than steel or concrete, what that means is that the building requires more additional lateral bracing than it would otherwise. So lateral bracing from wind loads, for example. So there's a few different ways you can do that, and we explored some options. One of them is simply providing some steel diagonal bracing on the perimeter of the building. Well, and I should mention that if this building were a residential project, then there would likely be a lot more interior walls.
I found this on the web.
And that would provide that lateral bracing, but because this was an office spec project, that meant completely open floor plates with the exception of the core. That's why we needed that additional lateral bracing. So one way to do it is perimeter steel bracing, which is what they did in T3 Atlanta. This is the interior image of T3 Atlanta. We felt like for our particular project, this wasn't what we wanted aesthetically. We didn't want to highlight any of that steel bracing. So we also looked at, well, what if we move that steel bracing to the core? This is an unfolded section of a few of those, well, a couple of the core areas. And unfortunately, because we had so much ductwork and sprinkler pipes and plumbing coming out of the core and openings that we needed, there wasn't enough space for the steel bracing. So then we decided to go with having just thicker concrete core in the center, which you can see here that I'm outlining. And that's really what's providing the lateral bracing for the project. And then that meant that the rest of the floor plate could be completely open. So we were really happy with that solution. But it's something to keep in mind when you're building with mass timber. And then always in the back of our mind, while we were looking at the structure, the kind of the bigger moves of the structure were these double height spaces, or these convertible single to double height spaces. These were really important to us. Like I said, we wanted to make sure that we designed in what would be required for a tenant to convert the floor plate in the future, so that they would be more likely to do it. You know, you could do it anywhere with this building, but unless it's easy to do, we didn't think tenants would actually utilize that function. And it turned out to be, I would say, I think more straightforward than we expected. In an ideal scenario, if someone were to take over the entire building, they could connect all of these double height spaces. So I'll point out on a floor plan, again, a typical floor plan. In the darker yellow, this is a future double height space, or future open to below space with an adjacent future double height space. There's always two on each floor as the double height spaces kind of wrap up around the building. And really what it required was, go back here, just an additional west-east beam that was put in, two of them at each floor, so that you could simply remove this part of the floor plate and this part of the floor plate. And those beams weren't even that deep, or in the end, all that expensive. And it also meant, what also happened is that there were dry connections rather than glued connections at these moments, so that it is easier to remove the timber slab, and a hairline joint in the concrete topping so that you could also remove those slabs. So, you know, it remains to be seen at this point which tenants, again, are coming in, and whether or not there's definitely a scenario where tenants may come in and want this future double height space made before they even move in. And so part of the project may be built with these double height spaces. They may all be built with single height spaces, and then hopefully tenants will take advantage of this in the future, and we'll see. So here you can see on the left, the single height condition versus the double height condition. And this here is the cross beam. Okay, so during the design development phase, during this phase, we really were focusing on the systems and how do we integrate the systems into this mass timber structure. As I mentioned, we wanted to expose the timber as much as possible, which meant exposing the timber ceiling, which meant then exposing all of the ductwork and other systems that would be, you know, traditionally enclosed in a kind of drop ceiling in a typical, especially in North America, typical concrete or steel tall building. This is an image of a typical bay and structural bay. And you can see, for example, what I'm talking about, what kinds of elements are going to be exposed. So we had a lot of overhead ductwork. These are, here is a row of sprinkler heads. Of course, we have lighting. And then what's also not shown in this image is a lot of electrical conduit, that some of which would be pre-placed and some of which the tenant would provide. And there are a few different ways we looked at, how we can arrange all of this. It required a lot more coordination with our engineers than would be in a typical project, since all of this is exposed. We did, at this point of the project, we had the whole thing in Revit. So that was very useful, because then we could all basically do walkthroughs and just look around and make sure that things were aligned where we wanted them to be, and make sure that there wasn't a duct, hanging out somewhere below a beam, something like that. So we came up with a system of layering the different systems, which meant first we would have sprinkler pipes as close to the ceiling as possible, then below that ducts, and then below that lighting fixtures, so that we created a column with all the lighting fixtures, because all of these things overlap. And in terms of the ductwork, which is really the most present system, what we did is, I think that this is probably pretty common on a lot of mass timber projects, but we utilized upturned mass timber beams, which are identified in green. And an upturned beam is simply a beam where the top of the beam is aligned with the top of the slab. So it may be as deep as the other beams, but it doesn't appear as deep because it's pushed all the way up to the top of the slab. So all of these upturned beams in green were located here so that we could run all of our ductwork around the core. So as it comes out of these mechanical rooms, it just wraps around the core, and then it feeds out into each bay, running parallel to the deep exposed north-south beams. So that way, we felt like, okay, at least if all of this is exposed, if we run it all north-south parallel to the beams as much as possible, so nothing's crossing under the beams, then we're going to have as clear of a, or clean as a, of a ceiling as possible. This is an image of T3 Atlanta, and you can see what I'm talking about on the right-hand side. This is the core wall, and here is an upturned beam. These are the typical deeper north-south beams. And you can see, well, what will happen, what's not shown in this image, is that some of this ductwork will then run out along in parallel to the deep beams. But the upturned beams provide a place for you to push all of this major ductwork up to this, as close to the ceiling as possible. And there are other ways to do this. This is a project in Brooklyn, actually pretty close to 3XN's New York office, where they just ran a lot of their services in this wood lamella zone that they created to at least partially hide that. You can also see some of these beams have holes in them, which is where they were planning to run electrical conduit. We did not opt to do that, mostly because of cost, but also because we felt like as long as we created clear zones in which to run conduit for tenants in the future, then that would be enough in terms of keeping the general look clean and, again, exposing as much of the timber as possible. And there were a few places where we felt like we did not want to see any of the ductwork. And those were these 3 public double height spaces that to us were really sacred. And we felt like this should all be all about the wood and have the least amount of services visible possible. So in these 3 spaces, this is the lobby at the base, and then the first community space, and then the second one, which serves as really a multi-purpose event space. In these spaces, we were able to find other ways to just blow air in, other ways to deal with HVAC by using these walls that are surrounding the spaces so that we could keep the ceiling really clean and clear. What's not shown are sprinkler pipes, which will run in the same direction as and above the lights. But other than that, we were able to keep these spaces really, really clear. And then during the construction documents phase, of course, it's all about lots of little details and like little things that came up, some of which we expected, some of which we did not expect. But I think it's worth mentioning that perhaps different from, again, building with steel or concrete, with mass timber, since these are prefabricated elements, the manufacturer that you go with, that can make a difference in terms of perhaps what sizes are available, but more likely what sorts of details you may have, like connection details, things like that. So there were some things that we knew we wouldn't know yet in the design process until a timber manufacturer was selected. And then we would have to and be able to work out some of these final details. So we didn't know the exact final size of all of the columns and beams, and we didn't know what all of the connection details would be until we had selected the timber manufacturer, who ended up being Nordic. So it's just something to also keep in mind that some of those final details you can't really figure out until you get closer to the end of the project. So I would say construction documents and administration a bit blurred. I'll talk a little bit about the facade. So as I mentioned, it's a curtain wall system, which was different from the former 2 T3 projects. Those were both window wall systems. And it's a double glazed IGU low E coated glass with these exterior lamellas, we call them, applied to the majority of the facade. They're left off of the areas that are the stepping portions of the facade, so that we really highlight the stepping portions of the facade. We looked at doing those. We wanted those lamellas partially for shading, and then also for kind of giving the building a bit more mass feeling to it, rather than just being a big glass box. And we felt that that was appropriate with the use of mass timber. We did look at the exterior lamellas being timber, but because of cost reasons and fire code issues, they're aluminum instead, but they're a color that works nicely with the mass timber inside. And, you know, we wanted to just kind of create this feeling that the lamellas are just running straight up beyond the perimeter beams here. And we definitely worked to make sure that, this is another thing that until we knew what the timber manufacturer was going to be, there was a couple of other things we couldn't make decisions on. For example, the color of the spandrel. The spandrel glass shown here, we wanted that to match the timber as much as possible, so that from the exterior, when you see the edge of slab, even though it's not truly the edge of the timber slab. We wanted it to look like that as much as possible. And we couldn't make that final decision on the color of that exterior spandrel glass until we knew who the timber manufacturer was going to be, and therefore what their timber was going to look like, what the species of the timber was going to be, things like that. So that spandrel is highlighted in yellow here. And we were able to squeeze this whole curtain wall spandrel area as much as possible so that this face of the perimeter beams was completely exposed to the exterior. So that was really our driving decision or factor in terms of what size this would be, this connection piece where the curtain wall is connecting back to the slab. We really wanted to squeeze this as much as possible to expose that perimeter beam to the exterior. On the right-hand side is showing in a future double height space, when that's converted, what that looks like. And it's really straightforward. Basically, they would be able to remove the timber portion and the concrete topping portion of the slab above, and this perimeter beam would have to stay, which we were okay with. But this perimeter beam stays here in order to provide lateral support to the intermediate column. Which leads me to a few other small things that came up during the construction documents phase. One which I mentioned is that we didn't know the final sizes of the columns and beams until we had selected the manufacturer. And as you all have probably learned about already, the way that mass timber protects itself is through, in case of fire, is through charring. And so once this charred layer has burned, that actually protects the remaining ambient wood layer. And what that means, and why that matters in terms of design, is because it means you get larger beams and columns than you would if you didn't have to worry about that charred layer, because the ambient layer, the interior layer, is what's providing all the structure. And then you have to provide additional depth and width to your columns and beams for a charring layer in case of fire. So you do get larger columns and beams than you would in a typical concrete or steel building, which I think is something, I think it's okay. And we just, again, kind of celebrated that. In general, we have lots of different sizes of columns and beams in the project, because while you could standardize all of them, it's more efficient, it's more cost effective to only require the minimum size number that's needed structurally and for fire protection. And so what that means is we do get a lot of variation, but again, it's just something we're kind of embracing and just celebrating. It's not all going to be perfectly exact, but again, which you might get in another kind of project, but in this project, we are just celebrating that. So for example, this center column of the event space, we certainly pushed to have no other horizontal beams coming into this column to support it, since it needed to be this grand open space. And for event purposes, we didn't want to have any of those horizontal beams. So this center column is much, it's hard to tell in the rendering, but is much larger than the other double height columns in the space, because it doesn't have that additional lateral support. But that was something that we just embraced as it is what it is. It's being efficient for itself. And then another thing to consider, or another thing we considered in this phase, are all of the various connection details. And we were excited that Nordic was able to find a way to hide basically all of the hardware in the connection details. These are just generic photos, but on the right-hand side is what our connections glulam and CLT connections will look like, which is basically, you don't see any of the steel that is required in some of these connections. And where there is steel, a steel faceplate or something like that, it's hidden with a matching piece of wood. And I think in some projects it makes sense to expose all of these connections and these steel members, or elements, I should say. And then in other projects it makes sense to have them all hidden. And we were excited in our project to be able to hide all of that. And there's a lot of other, new products coming out with regards to NLT and CLT and glulam. So for example, one product we looked at is acoustic NLT, and we looked at this for using to use in our event space on the ceiling, which needed additional acoustic support or material. And it's essentially NLT that with wood members that are longer than needed structurally, and then you route out between them and add some acoustic material. So I'm sure there's going to be in the future, many more kinds of products like this, but it's interesting things to look into, perhaps for your project. And maybe the last thing I'll touch on in terms of what we looked at is, how can we then find other ways to celebrate wood in smaller ways, in more, let's say, decorative ways in the project. So for example, we looked at employing Akoya lamella wall systems in the lobby. And, 3XN is using timber and Akoya on several other projects. This is the Royal Arena, where these exterior fins are also Akoya kind of laminated together. So it's a sort of mass timber, but more decorative, functional in terms of shading. And then also the Sydney Fish project in Australia is utilizing mass timber to create this large curved roof element, which you can see here. So, I would say T3 really, I guess, embraced the simple kind of erector set way of building, because that was really efficient for the project and made a lot of sense for it being an speculative office project. But of course, there's a multitude of ways that you can use it. And that's about all, but here's my contact information. So please feel free to reach out to me via email if you have any other questions about this project or mass timber. And thank you to all the organizers of the event. It was an honor to be here and talk to you all. I'm happy to take any questions.
Thank you, Elizabeth, for this wonderful and really precise and in detail going presentation. I will open up the Q&A for you all, and let's have probably switch on all the cameras and give a short applause to Elizabeth for this insights of I think becoming beautiful building. Thank you very much.
Thank you.
So yes, the floor is for the students and to have questions to Elizabeth. And are there any? I hope so. It's a big building.
I'll go first then. Can you hear me?
Yes.
Thanks for the lecture. It was great. I'm interested if in the future you think that through this project enough experience was generated to convince clients that have no experience in mass timber construction of the benefits or reasons to use this kind of construction.
Mm-hmm. Yes, I think absolutely. I've already started seeing in the U.S. smaller developers looking towards building with mass timber, and I think I'm sure part of it is because of these larger developers such as Hines who are taking it on, and I think showing that it again that it's very desirable to clients, especially right now. Desirable to tenants, especially right now. And so I think that they're very savvy marketers, and they're using it to their benefit to promote mass timber to particularly millennials, and again, like I said, creative office tenants, as what's kind of cool right now. But I think that it's selling, and so I think that certainly smaller developers and other clients are noticing that and are going to get on board with that. And I think also, of course, it's aligning nicely with the U.S. is behind in this, but with some American cities starting to require more green building certifications and things of that sort, that obviously mass timber construction aligns well with that. And they're again noticing that's palatable to future tenants, to say this is a green way of building, and yeah.
I would like to ask a question. I'm sorry,
Sure.
My camera doesn't turn on for some reason. In the beginning, you talked about the research branch of your office, that GXN, they researched building as a series of components for disassembly.
Mm-hmm.
There's my video. How did it translate to the final project, seeing that some of the connections are hidden from sight, like the steel connections? So
Mm-hmm.
how did it translate to the details?
Yes, that's a good good question. Well, some of those details, while they're hidden, they're still dry connections, meaning no glue is being used. Some of them, given the realities of building a project of this scale, are not dry connections, and